everyone. Welcome back to 5th grade math. Yesterday, we read Multiplying Menace, The Revenge of Rumpelstiltskin. And the reason we read that book was to get our minds thinking about what happens when we multiply numbers that aren't whole numbers, okay? So as a 5th grader, we are working on this standard. We are applying and extending what we already know about multiplication, and we're using that knowledge to multiply fractions or whole numbers by fractions or mixed numbers, okay? So today we are going to be looking at multiplying whole numbers by fractions and whole numbers by mixed numbers, okay? So I am going to pull out some of my fraction pieces today. However, I know that at your house you don't have fraction pieces, most of you. So one thing that you can do is take just some plain paper, notebook paper, and cut it into strips. And we're going to use these also as our fraction pieces today. Okay. So the first thing that we're going to do is look at this word problem. And you'll notice that there are no numbers yet. So there are blank packages of pencils on the desk. One full package weighs blank pounds. How much do all the containers weigh? So I like to have word problems without the numbers because then I can think about what it's actually asking me to do. So, you know what? Let me put in, let's go back in time. Let's go to 3rd grade. Put 3 packages of pencils, okay? And each of those packages, one full package weighs 4 pounds. So each package weighs 4 pounds. How much do all of the containers weigh? So if you have 3 containers or 3 packages of pencils, 3 containers of pencils, and this one weighs 4, this one weighs 4, and this one weighs 4, what math problem are we doing? We're doing multiplication. We're doing 3 groups of 4. 3 times 4 is 12. All right. So let's go a little bit forward in time. Let's go to 4th grade, okay? So we're going to work completely and totally with the same word problem several times, so hang with us. So I've got 3 packages of pencils, and one full package weighs 1/4 of a pound, okay? So if I have 3 packages of pencils, and they each weigh 1/4 of a pound. As a 4th grader, you did 1/4 plus 1/4 plus 1/4, or 3 times 1/4 equals 3/4. Now, in our first problem, 3 times 4, we ended up with 12. We multiplied 2 whole numbers, and our product was larger than both of our numbers, right? But when we did 3 times 1/4, our product was 3/4. That's not larger than both of our numbers, is it? That reminds me of the trick that Rumpelstiltskin used in our story yesterday. What if we did 3 packages of pencils and one full package weighs 2/3 pounds? Well, instead of getting out 1/3 by itself, I'm going to have 3 groups of 2/3. There's 2/3, 4/3, 6/3, right? Can you think of another way for me to represent that? If 3 times 2/3 we said was 6/3, that's an improper fraction. Can we make wholes? So based on my denominator, how many makes a whole? So my denominator is 3. That tells me that 3 of these pieces make a whole. So now I have 3 packages that each weigh 2/3 of a pound, And that equals 2 pounds, right? Let me grab a marker here. We need to write some of this up. So we said 3 times 2/3 equals 6/3, which has the same value, and we just proved it with our fraction pieces, as 2. So all of what we've done so far has had to do with what you did as a 4th grader, right? Because you did multiplication with fractions and a whole number. Let's throw in some mixed numbers, okay? So we still are going to keep 3 packages, okay? And each package is going to weigh 1.5 pounds. Now, I told you guys that we were going to use some of these fraction strips because that's something that you would actually have access to at your house. You could cut up some paper. So we are doing 3 packages, and each package weighs 1.5 pounds, right? All right. I lost my scissors and they're right here. All right, so 3 packages, and they are 1.5 pounds. So let's represent that with our fraction strips. So if I have 1 whole pound here, and then I'm going to take this one and make it into halves, I'm going to label these pieces so that I know what fraction I'm using. Okay, so each of these parts are going to be halves. Now, I'm not going to use both of these halves right now, but I want to go ahead and label them. All right, and then this was my whole. All righty, so let me get it to where you can see my floor here, see what we're working on. I'm moving you around a lot today. I'm sorry about that. Okay, so there's 1 whole, okay, and 1/2. So I have 3 packages like that. So here's another package, 1 whole, 1/2, and I've got to make another 1 whole, and 1/2 to represent this problem. All right, so how much do all of the containers weigh? So I'm doing 3 groups of 1 1/2. Now, to put those together, I can look at my holes first. How many holes do I have? I've got 3 there. Now, I have also 3 halves, right? So I know based on my denominator that 2 halves make a whole. So I can put 2 of those together. So now I have 4 holes and 1/2 of another. So my problem, 3 times 1 1/2, what would the product be? Would be 4 1/2, right? So let's change our problem one more time, and then tomorrow we'll dig into looking at when we're multiplying 2 mixed numbers, and then from there 2 fractions, okay? So let's change it to where we have 3 packages of pencils. That's all we've got. But the weight is going to be 2 3/4 pounds. All right. So we're going to get our paper strips again. 2 3/4. All right. So let's get that made. So I know that 1 package is going to be represented by 2 holes, right? And 3/4. So each was 2 3/4. While I'm getting this folded, I want you to make a prediction. I don't want you to solve it. I just want you to estimate what you think this answer is going to be close to. I know that 2 3/4 is closer to 3, Anybody else notice that? So 2 3/4 is closest to 3. So 3 times 3, I'm thinking our answer is going to be close to 9. All right, so I folded this into fourths. I'm going to label each of those fourths like so. So I know what size parts I cut this into. So there's my fourths. And I need 3 of those to represent one of my containers of pencils, one of my packages. All right, so there's 2 3/4. Okay, so now let's do our second container. It also weighs 2 wholes and 3/4. I'm going to do the same thing. Fold my paper into 4 parts. I do it by going half and half again. I'm going to label each of those parts into fourths so I know what I have partitioned it into. And I need to do one more container, right? So, got 2 holes. You label them as 1 hole. I have to put those up here for the time being. And you guessed it, I'm going to do fourths again, right? I'm going to label them. All right, so 2 3/4. I've got 3 groups of that. Okay, so we estimated that our product would be close to 9, that our containers altogether would weigh close to 9 pounds. That's a lot of pencils, y'all. So let's put our whole numbers together first. So I've got these holes. I love using fraction pieces for this because I can move them around the way that it's easiest for me to see it. So I have 3, 4, 5. I have 6 holes up here. Now, I know, based on my denominator, that it takes 4 of these to make a hole. So there's 4. There's another 4, so I made 2 holes, and then I have a leftover. So my product is 1, 2, 3, 4, 5, 6, 7, 8, and 1/4. We were pretty close when we said it was 9. So, you can use your own fraction pieces, okay, and make them with paper to solve some different multiplication problems. So I want to give you a couple that if you want to try them, you can. I'm going to hold them up here. And then tomorrow, we'll look at multiplying 2 mixed numbers, okay? So here are 2 problems that you can try, okay, by using the paper strategy, using your fraction pieces, okay? I'm so glad that you joined us, and we will see you tomorrow, I hope. Bye.